Welcome to September's Leetcode challenge. This problem is called Transform to Chessboard. You are given an n times n binary grid board. In each move, you can swap any two rows with each other or any two columns with each other. Keep in mind it has to be the entire row or the entire column. Return the minimum number of moves to transform the board into a chessboard. If the task is impossible, return -1. So what's a chessboard? Well, basically it's a board where no zeros and no ones are four directionally adjacent, and it looks like this checkerboard or chessboard pattern that we all are familiar with. Okay, so before we attempt to do any recursive backtracking methodology like I did, let's stop right there because that is never going to work. It's just simply too difficult, and it's time complexity is going to be way too heavy for that to ever work. So what are some characteristics of this board that it needs to have in order for it to be transformed to a chessboard? Well, let's think about this. Well, the first thing that we can kind of tell needs to be true is that for every row there has to be, well, if it's an even number, there has to be half ones and half zeros, right? We can see here there's two zeros and two ones, two zeros and two ones, and the same needs to be true for all columns. Now, what if it's flipped? What if it's an odd number of columns and rows? Well, that makes it a little bit difficult, right? Because then we'll have to have, I guess what you can say, n divided by 2 minus 1 number of ones or zeros, and n divided by 2 plus 1 number of ones or zeros, and that has to also be true. Okay, so we kind of intuit that there's some characteristics here that need to be true, but there's a big one that actually we can take a step further and realize this also needs to be true. One of the things we should realize is the actual number of patterns for each row and each column needs to be at most 2. So if you don't believe me, just think about if we had like something like this. Would this ever be able to be transformed to a chessboard? And you can kind of tell already, no, it's not, because even though for every row we have all these ones, at some point, at some column, we're going to have 3 ones, which means it's never going to work because we can flip this, you know, to put that 0 there, and that's fine. But now this 1 is still here, and that 1's going to stay here. So no matter what we do to flip, this is never going to be a chessboard, right? So what that means is whether there's an odd or even number of rows and columns, there has to only be a pattern of two versions at the most for all the columns and all the rows. So that's interesting, right? We have to have 2 patterns for every row and column. Okay, now once we figure that out, actually, then it's just a matter of going through all the rows and all the columns and comparing it with the pattern that we actually want. So the patterns that we actually want here would be like either 0 1 0 1 0 1, or it would be 1 0 1 0, right? And what we can do is just go through every row and every column and check to see how many of these are different. And the number of them that need to be different have to be even. Okay, and that's actually going to be the number of flips that we make. So here with this example, we can check, okay, how many of these are different, and we can go through and see, okay, these are the same, these are the same, this is different, this is different. So we have 2 moves, right? For this, so this column, we have to move, well, it'd be 2 divided by 2, because each time we do 2, we take care of 2 columns, right? And that would mean that would be 1 move. So we can actually calculate, go through all the rows, or not even all the rows, just the 2 patterns that we have, and check with these 2 patterns, how many would we need to flip? And as long as that number is even, we'll take the minimum for the number of columns that we need to flip, and the number of rows. We'll have to also check the rows to do the same thing. And to make it a little bit easier, what I'll do is transpose this board right here and do that same algorithm for both rows and columns. All right, so let's first initialize n to be the length of board. And like I said, we need to first transpose, right, and get another version of this board that's going to be transposed. What I'll do actually is just cheat. You can certainly write a function to do the transpose, but I really don't feel like that. So I'll just use this numpy and do transpose for the board. And let's just make sure that looks correct. Oops. So this should look like, you can see 0, 1, 0 is now like right here. So if we looked at 0, 0, 1, 1, that 0, 0, 1, 1 is on the first row. So these are the columns now. Okay, great. All right, so now that we have that, let's first figure out, do we only have 2 patterns for both the rows and columns? Okay, so what I'll do is we'll call a counter, and this will be for all the rows. And this will be a counter object. And what do we want to pass in? We want to pass in for, I guess, row in board. And we're going to make this a tuple so that we can actually do the counting. And what I'm actually going to do is make this into a list as well, because we know there's only going to be 2 keys. Well, there should be anyway. And I'll show you why we have to make this into a list in a little bit. So we all want to do the same thing now for the columns, and this would be for board T. Everything else would be the same. So let's print this out and look at what we're looking at, just to make sure that we're not getting lost here. All right, so you can see we have the pattern 0, 1, 1, 0 and 1, 0, 0, 1, and there's 2 of them. So that's what it indicates. And I'll just put that in the comment here just so we can keep track of what these counters look like. Okay, so the first thing is, if the length of count R or the length of count C is not equal to 2, if either of them are not equal to 2, then we can immediately know there's no way to make this into a chessboard. So we can return false. So if length of count R not equal to 2, or length of count column not equal to 2, return -1. Now there's an edge case, or I don't know if it's an edge case, but we also need to worry about, it's possible if we have an even number or odd number of rows and columns, we can have something like this. Okay, so that means these, we have 3 of the same pattern and 2 of the same pattern, so they're not equal to one another. Obviously one of them is kind of on its own. So what we'll have to do also is check to see if this condition holds. Either they're the same here, like we have the same number of patterns to both of these, or we have one more on one of them if it's odd. So just to check that, we'll say if the absolute value, and this is why I had to make this into a list here. I have to say 0, 0. Otherwise, I have to find what the pattern is and put it in, and it just would be too much work. So 0, 0, which would be, oh, I'm sorry, we're not looking at the pattern, we're looking at the number that they appear. And we'll say 0, 1, 1. So this would be for the rows. And if this is greater than what, 2, that means this is no good, right? And same thing for the columns. All right. So now that we have that, what do we need to do? Well, at this point, if we're able to get past all this, that means we should potentially have a board that should be able to be formed into a chessboard. So now, like I said before, we have to compare it with this pattern that we want, the either 1, 0, 1, 0, or whatever, right? Or 0, 1, 0, 1. But we don't quite know what that pattern is until we get the length here. So what we'll do, I'll call pattern 1. This will start with 1, and we're going to multiply it, let's see, by n divided by 2, and I think we actually need to add 1 here as well. So what I'll do is just plus 1, and this will be a list, and we only want it to be the length of up to n. Now we also want to do the same thing for the opposite. equals 0, 1, and this we'll call pattern 2. Okay, so let's just make sure these patterns look right. All right, so 1, 0, 1, 0, 0, 1, 0, 1, and we have length of 4, so that looks good. Okay, so finally, we want to figure out, this is the main point, right? How many moves can we make, or what's the minimum number of moves that we can make? And to do that, all we need to do is check the differences between these patterns here and get the minimum one. So luckily, there's only 2 patterns right now. We know for rows and columns, there's only 2 patterns at the most. So what we'll do, let's see. We're first going to check, I guess, the first one here. Okay, we'll call this x1, x2, y1, y2, and this is just going to be the number of, the number of columns that we need to flip and number of rows that we need to flip. So all these start with 0 first. So for the first pattern, let's see. Okay, well, x1 will equal, I'll call it sum. We'll say 1, 4, I in range of n. We're going to check if count of r, let's see, 0, 0, 0. And technically at this point I just realized something. We don't need to check both patterns. We only need to check one of the patterns because we already know that this is going to be a mirror image of the pattern, right? So we only need to check one of the patterns, and we're just going to check to see, if it doesn't not equal the pattern 1 of I, and this one would be I right here, then we're going to output a 1, and we want to find the number of those. That would be the sum. Okay, so this would be, we're checking the count of rows, so we're checking the columns that we would need to flip, and do the same thing here for the y1. But this would be for the columns instead. Okay, in the same way we wanted to do it for the second pattern of 0, 1, 0, 1. And everything else should remain the same here. So now we have 2 potential values for the columns and 2 potential values for the rows. Okay, now what do we want to do? Well, first we got to make sure that these number of moves is an even number, because if it's odd, it actually doesn't make sense. We can't, flip 3 or 5 rows. So what we'll do is, okay, I'll say, let's see, how do we do this? X equals, I guess, for x in x1 and x2. Let's make sure that the sum is even. So if x is divided by 2 is even, then we'll output that x into here. And same thing for the y. All right, so now we have these candidates for x and y. All we need to do then is return, remember, there could be 2 of them, so we'll get the minimum of these 2, and we're going to divide it by 2, because that's going to be the number of moves, plus the minimum of y divided by 2. Okay, so let's see if this works. Okay, let's see, what did I do wrong? List, oh, okay. Simple typo there. Okay, so I really can't tell if this is working yet, but let's go ahead and submit that. Oi, okay, min is an empty sequence. Uh-oh. That shouldn't be possible. Let's see. How did that happen? So somehow it passed all this even though our input was not correct here. So let me see what oh, okay. No, no. 1, 1, 1. I'm actually kind of confused here. This shouldn't have worked. I think this is 1 actually. Yeah. Yeah, of course, that should be 1. So that was my mistake. For some reason I made that 2. It can't be greater than 2. The difference can only be 1 at the most, right? Okay, so hopefully I didn't confuse you there. Yeah, you can see this is pretty jam-packed code. There's other methods for sure, but they're all this complicated. So this question I particularly hate because it wasted a lot of my time, and I had to look up the answer. Sometimes I feel like all I do is look up answers and then try to understand them and relay them to everyone, and that's kind of discouraging because I want it to be all my own knowledge coming out, but sometimes these questions are really hard and I can't do anything about it. But hopefully that helped. I don't think this is a good question because it's really dependent on how much intuition, how much like logic, math can you pull out from this problem rather than like a programming question, right? So I don't know, but hopefully this helped and at least you can understand like one solution for it. All right, thanks for watching my channel. Remember, do not trust me, I know nothing.